welcome. So just a small thing about me. I started working with Qt as a student on KDE a long time ago. Following this, I worked for Trolltech and Nokia on the Qt framework. I worked on many areas of Qt. But I left in 2011 to create my own company. We're doing consulting, so contact us if you need. Yeah, I like meta objects. So back in Trolltech, Nokia, I was working a bit on the mock. I also did a mock-ng, which is basically re-implementing mock using libclang as an experiment. Verdigris, which are presented earlier, which uses templates and macros to re-implement the mock. And then finally, why we're here today, QMetaObject RS, which is basically the same as Verdigris or mock, but in Rust. So, are you familiar with Rust? Who of you have ever written at least a hello world in Rust? So a third, a lot. So Rust is a new language, or relatively new. The 1.0 was in 2015, and their slogan used to be fast, reliable, productive, big three. So fast because it's the same philosophy as C++. It's compiled and optimized with LLVM. It uses those concept called zero-cost abstraction, meaning that you do not pay for what you do not use. And when you use something, it's as fast as if you would write it yourself in the most performant way possible. So that implies that there is no garbage collector or additional runtime. So same as C++. But contrary to C++, who has undefined behavior all over the place, Rust tries to help the programmer by being reliable. And it's memory safety, so that means no use after free, no buffer overflows. And according to some research from Microsoft, 70% of their security issue were because of memory safety issue. So a whole class of bugs that you do not have with Rust. Rust was invented by Mozilla because they wanted to have their browser with threads. They wanted to use threads in their rendering engine, and they couldn't do that in C++ because it gets too complicated too quickly, with races condition all over the place. But in Rust, thanks to the type system, you can do thread codes and be at peace. But of course, when you really need this little extra performance, you can still call unsafe and then use row pointer. But in practice, you normally do not need to use so many row pointer in the high-level code, especially when you do UI. And productive, because Rust is a language from the 21st century. It comes with the tools from this era, and all you need to be productive. So just as an example, in Rust, the code commands are part, testing and documentation are part of the language. So you can just use cargo doc, and it's going to generate some HTML for you. And it supports Markdown and all the modern things. There's one line in the code command here that is not in the examples because it's not relevant to the example. You just need this line to get the code run. Because when you do cargo tests, it's going to run your tests, including the code which was in your documentation, meaning that the documentation never get out of date or wrong. So the user can just copy paste and be sure that this is going to be working. So this is all great, but you're using Qt, you want to make UI. Can you use Qt from Rust? And there are several solutions out there to use Qt. So for example, one of them is called Rust Qt. What an original name. And it's basically it automatically generates Rust binding by parsing the the Qt header. And so this kind of work, but the problem is that C++ and Rust are different, and it's not mapping really one-on-one. So the concepts from C++ do not map properly to the concept from Rust. And so when you have a huge API, the huge API of Qt, you cannot really, in an automated way, make really usable Rust-friendly idiomatic bindings. So this is gonna still need a lot of unsafe, and need a lot of raw pointers, and not a nice API. Another project is called the Rust Qt binding generator. And what this does is that you have to write a JSON file with the interface. So each time you want to expose an object or a model from Rust to to Qt, then you will write a JSON file with all those properties, and then it would create both Rust code and C++ code that helps you to integrate the two together. But this is still a bit cumbersome because you still have to run, you still have to do this extra step. And I didn't really want that. I really wanted that you would write your Rust code just as if today you would write C++, and it would just magically integrate with QML. And this is what I did with this QMeta object rs create, which is the library I wrote. And so what it does, it manually written binding for a very small API surface, just enough to run QML, and a way to expose your Rust object to QML using small macros exactly the same as Qt, or similar to the Qt macros. So since the other half of the room didn't know Rust, I'm going to just present quickly. So there are some similarities between C++ and Rust. C++ has class, Rust has structures. You also have private or public member. By default, everything is private unless you specify that it's public with a public keyword. So in C++, you have member functions. You do not have that in Rust, but you have associated functions. So it's just in a different block. You just separate data and behavior. But in practice, it's just the same as a member function, only that you need to be explicit about the this pointer. And again, everything by default is private unless you specify public, and also everything is const by default unless you specify mutable. C++ has virtual functions, and you can derive. You cannot derive in Rust, but you have a trait, and traits basically serve the same purpose as virtual functions. Well, the difference is that it can both be a static dispatch or dynamic dispatch, but in practice, you can emulate what you have with virtual functions with trait. And you have destructors, and you do not have constructors in Rust, but you use static functions to emulate constructors. So in C++, like in Rust, you can pass by value or by reference. Passing by reference in Rust is called borrowing. And the key to understand that where the difference is a big difference is that in C++, when you pass something by value, if you don't specify anything, it copies, unless you explicitly call move. While in Rust, it's the opposite. If you don't specify anything, it's going to move the object, unless you say, I want to copy using the clone function. And what happens if you use something after? So you just moved hello, and then you just wonder what's the size. And well, in C++, it's not, normally you're not supposed to do that. You're not supposed to use object after they've moved, but there's nothing that prevents you from doing that. In Rust, if you try to access the object after it's been moved, you get immediately a compilation error saying that you're using something that has been moved, so you're not supposed to do that. With the exception, for example, for integers and other trivially copyable types, which then move and copy are the same. Let's say I'm implementing a XML parser, and I want to be fast. I don't want to copy strings all over the place, so I'm going to use string view to store my result. So I'm going to parse a QML. I'm going to parse a string, and I'm going to create this XML element, and I'm going to store a string view in there. But as you are probably familiar with the pitfalls of string view, is that the string view is only valid as long as what it points to is also valid. So in this thing, you get the problem because the string that you're using is getting out of scope. So when you're trying to use the string view, which points to the inside of the string is already out of scope, so you're pointing to dangling memory. In Rust, however, it's gonna we're gonna annotate here with a it's like a bit like a template parameter, but it's a lifetime. So the single quote with a name is naming a lifetime. So this is a reference to a string. It's the same as a string view, but we tell the compiler that it's what's the lifetime of it. So the parse function, we tell that the return object still has the lifetime of the string we borrowed in the parse function. So when we try to use it from a string which would get out of scope, we get a compilation error telling that we're using some values that we are not supposed to use. And so this is the whole idea about the safety of Rust, is that it checks at compile time that all the lifetime of your objects are correct. So Rust also has macros. C++ also has macros, but the problem, say you want to have a local variable called slots, and suddenly you have strange errors, but this doesn't happen in Rust because if I name a macro, macros are in a different namespace, and just like, so all the main problems of C++ or C macros are avoided by Rust. There are two different kinds of macros. So here, by the way, this is how I create a class in foo, which I'm going to expose to QML, and then we can see that we have those macros. And so this is using the macro rules, which is one way to declare macros, in which it's a bit, I'm not going to explain how this works, but basically on the left, you have what you're going to match. So I'm going to match a type and then some other things. And then I'm just going to expand to a type. So a property here is just a property of type U32, and then this is ignore for now. In Qt signal, it's just going to expand to this kind of thing, Rust signal, and then some function signature. But this is not really how the meta object is constructed. The meta object is constructed via this derive keyword. So custom derives is another. It's called a proc macro derive. That's how you implement. That's basically where the whole QMeta object creation is done. So the way this works is that as an input you have a stream of token, and the output of the function is another string of token. So everything which is in there is going to be passed to your function. Then you can, in Rust, you can do anything. You can open file, even connect to the network if you want. But I don't recommend that, but you could. And then you're just going to return some other code, which then gonna be parsed again by the compiler. And so this is where we're gonna implement the meta object. There are other macros in Rust. And the principle is the same. Again, you get a token stream and you return a token stream. So another missing piece before we can implement this library is how do we integrate with C++, because Qt is in C++, so we need to integrate with C++, but Rust can only integrate with C. So that means that we need for every function every code in C++ that we need to call, we need to wrap it into some external C function, which then we can code from Rust using this foreign function interface. So this is going to be an unsafe function. And it's a bit fastidious to do because there are so many functions to do. But then enter the C++, the CPP crate, which is another crate I'm contributing to. And the idea is that you get a CPP macro, and within the CPP macro, you can write C++ code. And this C++ code is going to be extracted in a different file, and in many small functions, external C functions, and then called from this. So that means that you can just write the C++ code within the Rust code. Yeah, of course, you need to use the unsafe keyword because anything can happen there. But that's the way we can wrap C++ code from Rust. And so that's how the QMeta object RS works. So this only exposes the API for QML, but this is how this application looks. So from your main function, you're gonna, well, you have also a macro that does like what QRC does. So it will bundle all your QML files inside the binary, just like QRC does. You're also gonna do QML register type. It's the same as in C++. It's like the same as, so you're gonna register your to-do type as with the name to-do. And then you're gonna run your own engine with the file. So in this case, it's in the resource system. So this just wraps the C++ API for starting an engine. Then you have your to-do type, and then you're using a bunch of macros to. But it's in Rust, but it's the same principle as in Qt. So you say that you have properties, you have signals, methods, and so on. And in this case, I'm telling the system that I inherit from QAbstract list model, because I also expose QAbstract list model as a trait. So the trait that we're going to implement for our class. And so basically, we are just going to re-implement row count, data, just like for a QAbstract list model, only in Rust. And as we see, we also use QString, QVariant, and so on. And this is also the API provided by the crate. And it just wraps the C++ API for that, but it doesn't have any overhead. So in the sense that QVariant, the QVariant that we return is the same as returning a QVariant from a C++ function. There's no unneeded copies or anything. So the QML is just QML, nothing special there. It's only that you instantiate a Rust object instead of a C++ object, but you don't have to know that. Another feature is plugins. So QML has this. So for example, you can use QML scene and you can tell it to load some plugins, and so this is basically the code based on an example from Qt declarative, and it's basically the same thing. So we have this time model implemented in Rust, and we implement a QML plugin. We inherit from we tell now that we inherit from QML extension plugin with a Qt plugin macro. And this just works. So Rust will just create a dynamic library that is going to be loaded as a plugin. So that's it. So I hope that you're going to check it out, and you can hopefully you're going to try Rust and see if you can do if you can use Qt from Rust. Is there any questions?
How does the Rust borrow checker and the QML memory model integrate? Like, if I pass a Q object to the engine, does the borrow checker know that now the engine owns that object?
Yes. So that's yes. So it's of course a bit complicated, but once you it's basically like a reference counted object, or so you just give the object to the engine. Well, in this case, when it of course depends how the object is allocated, but if the object is allocated by the engine, then the engine owns the object. And there are other ways to share the objects, but yeah, well, QML does its things and Rust does its own things, but overall, it's coherent. Any more questions?
Hello. What is supported in C++ to do with QML and that is not supported with your Rust solution, if there is any?
Well, so a lot. So currently, only a very small API surface is there. So since you can always yourself use the CPP macro, it's always possible to call but then you need to use unsafe and you need to wrap the code yourself. But if there's something that is not supported, you can always use the CPP macro to call yourself the C++ function. The best, of course, would be to contribute, if you need that, would be to contribute to add those missing parts to the crate. But I've only done what is the minimum, I think, to get the thing running. I mean, of course, there is a lot more that can be useful, and then we will need to extend the API. Any more questions?
I made you work out. Hey, what about bindings the other way around? I mean, what if in general you would be interested in importing a Rust library or components into a Qt C++? I mean, I know there are some basic like C code gen stuff, but
right.
What about Qt? Do you know anything about
exactly.
that?
So in general, Rust has this feature that you can export your function as C functions and generate C header for it. So in this case, it's no different. You would just, so that's nothing with Qt. I mean, you would just call your C function from C++. You would call this function as if it was C. In fact, it's implemented in Rust. But yes, you can of course do that and implement the logic in Rust and then call that from your code in C++.
Okay, thank you, Olivier.